Hello, Accelerated Chemistry students. This is Ms. Krista Foley, and this is your Chapter 9, Section 5 video notes all over the laws governing how compounds form. There are two laws that describe the proportions in which elements combine to form compounds, the law of definite proportions and the law of multiple proportions. The law of definite proportions tells you that if you have a chemical formula and you have those subscripts, the ratio of the atoms in the compound are going to be represented by your subscripts. And they can also tell you that the ratio of the atoms can also be expressed as a ratio of your masses. So for example, magnesium sulfide is made up of the Mg2 plus and the S2 minus ion. So if you have 100 grams of magnesium sulfide and break it down into its elements, you would obtain 43.13 grams of magnesium and 56.87 grams of sulfur. And that ratio, when simplified, is about 0.758 to 1 magnesium to sulfur. The magnesium sulfide example obeys the law of definite proportions, which states that in samples of any chemical compound, the masses of the elements are always in the same proportions. So the law of definite proportions is consistent with what Dalton thought about when he was talking about his atomic theory. Dalton postulated that atoms combined in simple whole number ratios. So if the ratios of the atom of each element in a compound is fixed, then the ratio of their masses is also going to be a fixed ratio as well. In the early 1800s, Dalton and others studied pairs of compounds that contain the same elements but have different physical and chemical properties. Using the results from these studies, Dalton stated the law of multiple proportions. The law of multiple proportions states that whenever the same two elements form more than one compound, the different masses of each element are in a ratio of small whole numbers. So for example, if we look at copper 1 chloride, which is green, copper 2 chloride, which is blue, both contain the same elements, but they're in a different ratio. Another example will be water and hydrogen peroxide. They're both formed by the bonding of hydrogen and oxygen. However, they have different chemical properties and formulas. So those are the two laws that talk about how formulas are founded and how chemical formulas and compounds are made. But let's talk about how we're going to practice all of this naming. This naming chapter has been very hard for a lot of you because we're not doing what we need to be doing outside of class, but also we're not grasping on how to do this. So let's come up with some very generic guidelines for writing names based on a formula. So the following rules for naming, you're going to follow the rules for naming acids when you have an H as the first element in the formula. If you have two nonmetals, then you're going to use prefixes to indicate the number of atoms for each element. And if you have a compound that contains a metal and a nonmetal, or a metal and a polyatomic ion, then you're going to use ionic naming rules. So if we were to look at this flow chart, I'd write this down in your notes because this will help you decipher what naming rules do you follow. And then for writing chemical formulas, if it ends in IDE, you're going to indicate that it's made of two elements. If it's ITE or ATE, that means that you have a polyatomic ion that includes oxygen somewhere. And then if you have prefixes, that indicates that your compound is molecular, so that means you have two metals. And remember, you're going to need to use Roman numerals after your cations. That shows the ionic charge of that specific cation. And this chart should also go in your notes because that will also help you to figure out how to name certain things. So you have a lot of practice ahead of you, so I'm going to let you go. And as always, all of the information on these Google Slides has been acquired and adapted from Pearson Chemistry's 2012 edition of the textbook resources CD and pearsonchem.com. Thank you so much. Have a good night.